Guys, welcome to Techie Now's powered by Newton School. I'm Abhishek. As you know, I'm a techie with 3.3 years of experience in full stack development and also have a great keen for teaching. I have like 4 years experience in teaching and I have been teaching to a lot of different kind of kids, India, US and everywhere. Okay, so I got an opportunity from Newton School. You know, they are a great platform which help you to bank a career in tech, and the best part of them is like no pay until you get placed with a package of 5 lakhs or more. That's the best feature they have. They have launched a product. The name you can see on the screen, Launchpad, right? So, and they are trying to provide free education to the country so that everyone can get a quality education. Okay, that's awesome, guys. Okay, now let's move to the next part, which will study in this video. So, we'll try to cover complexity. We'll see few examples of complexity, like we have studied about time complexity. We'll solve few questions and try to find out time complexity of different kind of algorithms. So currently, if you see, we will mostly focus on iterative algorithms. So let me annotate my screen. So what is iterative algorithms? Let's have a look. So now there are two types of algorithm. One can be termed as iterative, other can be termed as recursive. Okay, what are recursive? Recursive algorithms are those algorithms like they are basically functions. Like suppose the name of the function is fun. Okay, I'll call the same function within the function again. Okay, so calling a function within itself is called recursive. Okay, and like if we're using loops and all, it will come under iterative. Okay, okay, let's move to the next one. Yeah, so what will be the time complexity for this question? What do you guys think? Any suggestions? Okay, so the time complexity, like see, there is no loop involved. So how do we actually calculate the time complexity? So now see, here there are two things, A and B. So like these are constant, these are not changing, right? Okay, so what will happen? Sum will AB, this will also be always a constant, 10 plus 20 is 30. So the complexity will be O1. In time 1, this algorithm will execute. Okay, remember guys, one point should be noted. This time complexity are not accurate time. Okay, they are not accurate at all. They are just a representation that this will take O1, like linear time. Okay, the way if we change A and B, that doesn't matter. Like currently they are constant, but suppose we change A and the value of A and B, then also this will take the same amount of time. It will not take like what they say, like time will not behave in a very weird fashion. It will be always O1, right? Let's see another example. Okay, okay. So now let's have a look. Let's see the second example. Now you guys can see age equals to 10. This is an array, right? Now you want to access the third index. So that is 0 index, first index, second index and third index. So how I can access it? This is 0 index, first, second, third. So now if I want to access any element here, okay, so what will happen? So in this case, you guys can see if I want to access an element, it will always, I can directly access it. I just have to write the array name and I can access it directly, A3. However the big array is, however the small array is, no, not a problem, right? We can access A3 directly. So the complexity will be over. Okay, great. Yeah. Okay guys. Now let's look at this program. What will be the complexity of this code? So from now, what of all the questions that I saw, before I explain it, I want you guys to comment over the complexity of these questions. What do you think will be the complexity of this question? Do comment. Okay. And once you have commented, then let's come back and check out the answer, if the answer is correct or not. Okay, let's understand. So you can see how is this complexity behaving. The I is 1. Now what will happen? That means I is going from, this loop is running from 1 to n. Okay. So this loop is total running for n times. Am I correct? N times. Now since this loop is running for n times, so this will also be printed for n times. Hello Abhishek sir, right? Okay, now so what will be the, like, see, if we increase the value of n, okay, so you can see, like, you can relate like this. the time, like see, the time this program takes will be directly proportional to the value of m. If we increase the value of m, the steps will increase. If we decrease the value of, the steps will decrease. That means the number of time the print statement will print will decrease. So the thing is directly dependent on n. As a total number of times, n times, right? So the complexity will be O n. Okay. So this loop is executing a total of n times. So you can directly say the complexity is O n because there are n steps involved in it. Okay. Clear? Okay. Now what will be the complexity of this code? By the same logic we can go, right? Here, there we discussed about n step, right? Okay, remember guys, first comment the complex. Always write a question number, which question I am referring to. Then you can write the complexity, okay, in the comment. And let's see who gets the most correct options. Okay. So by this loops run for 2n times. So you guys can say, okay, total 2n steps are there. So the complexity will be O2n. Yeah, of course the complexity will be O2n, but there are few rules we'll remember. Suppose On is the complexity of any algorithm. If I multiply it by constant, like any constant, suppose k is constant, kn, or divide by constant, or add or subtract by constant, doesn't matter. Okay, the complexity will still remain O. Okay, we can easily remove the constant. So is it get clear? The complexity will be On. Clear? What will be the complexity of this code? Everyone, first comment. Okay, once you have commented, very great guys, come back here. So this loop will run for, you can easily guess it, this loop will run for how many times? N by 2 times. So the complexity will be O n by 2. Now we'll use the same rule. If anything is divided by a constant, okay, so what will happen? If any, the complexity remains O n, we'll remove k, right? The complexity of the code will be O n. Correct? Awesome. Let's go to the next one. Now what will be the complexity of this code? What do you think? So see, the first loop is running from 1 to n by 5. So you can say the complexity of the first part is O n by 5, which is nothing but O n, right? The complexity of this code will be O to n, which is nothing like O n. Now see, these are separate loops. This loop will first execute, then this loop will execute. So what is the total time that this program will take? On plus On, which will be 2 On, right? So basically like 2 On. So basically I'm if you know, multiplying n constant, like divide any constant, it will be still be On. So the complexity of this code is On, right? Let's have a look at this. Sorry, let's have a look at this code. The loop is running from 1 to n, okay, and this loop is also running from 1 to n. So let's see if I now here the problem is of nested loop, right? Nested loop. So if we have a nested kind of loop, how can we say it? Let's have a look. So see, first let's suppose the value of I is 1. For the value of I is 1, j loop will run for how many times? J loop will run for n times, 1 to n, right? When I is 2, j loop will again run for n times, right? Like see, I is 1, then this will come inside this loop will run from 1 to n, right? Then again the value of I will be 2, this loop will again run from 1 to n. This is independent of I, this loop will keep on running n times every time. I3, then this loop will run for n times. Similarly, when the value of I is n, this loop will again run for n times. So total, what is the total complexity? Total, there are n steps, right? So we have to count, like the total complexity will be sum of all the complexity, right? how much time, how much time this total take. So for here it was n steps, here n steps, n step, and so on n. So total how many n times are there? So n into n, right? That means n square. Clear, guys? Great. Okay, now let's go to the next one. I think that I made some, yeah. Okay, so what will be the complexity of this code? Always comment, guys. First comment your answers and then check if you are correct or not. Okay, so now there are two ways to do it. Okay, the first way, like we discussed just now, for nested loop. For I is equals to 1, I'll discuss both the way now. I is equals to 1, then j loop is running for n by 2 times. I loop is 2, then j loop is running again for n by 2 times. I is 3, j loop is again running for n by 2 times. Similarly, when I is n, j loop will run for again n by 2 times. So what is the total number of times j loop is running? N into n by 2, which is n square by 2. Dividing by constant will neglect, so complexity will be O(n) square. What is the other way we can see? So see, basically when a nested loop, basically what you can do, the complexity of this loop you know is n. Complexity of this loop you know n by 2. So basically n by 2 is still n. So n into n is n square. So you can multiply the complexity of this two together. So either this way or this way, whichever you finds better. Okay. Awesome. Now guys, let's understand the complexity of this code. Okay, so what do you think? What will be the complexity? Again, there are two methods, like they are in nested loop. So just now we discussed one method. So what will be the complexity of this loop? And this loop and this loop and the total complexity n cube, n into n into n. Or what can we use? We can use a simple thing. If I is 1, what will happen? Then and then j is 1. K loop will run for n times. Then again j is 2. J loop will run for n times. J is 3. The K loop will run for n times. Right? Similarly, j is n. K loop will run for n times. So what is this total? How many times these two loops are running together? N into n, right? That is n square time. And this is just for I is equals to 1. Then again for I is equals to 2, same thing will get on repeated. For I is equals to 3, same thing will get on repeated. So total how many times? This will continue to I till n. So total n into n square, which is nothing but n cube. I hope this is clear. Awesome. Okay, let's look at this. What is the time complexity of this question? Any guesses? It's simple. How many times this loop will run? This loop will run for root n times. So the time, of course, we don't write root like this in programming, but I've just written for now. Don't see for any specific syntax. Okay, so this will be root of n. Okay, complexity, simple. The number of times it is run. That is what we have to count. Right? What will be the complexity of this code? Let me see how many of you have given a correct answer. Okay, for this code. So now what can be the complexity? I want everyone to comment for this question. See, okay, because the complexity is quite simple. I into I is basically n, so it's basically I square is less than equals to n, so which is same as I is less than equals to root n, right? So the previous case, right? So the complexity will be over root of n. The same thing, just it was written in a different way, right? If there are 3 I into I is less than equals to 1. So what will be the complexity? I leave you for you. So let's see who gets it correct. Okay, not telling. If we replace this by this. Okay, now let's see what will be the complexity of this question. Now see, I don't know, like, let's see here. I mean to say, suppose you know the complexity of this line. You can say directly n. but I am not sure about, like, let's suppose I'm not sure about this complexity, what will be happen? Okay. Then what can happen? If I'm not sure, then we can calculate it a normal way. If I is 1, what is happening? J loop is running for 1 time, right? If I is 2, J loop is running for 2 times. If I is 3, J loop is running for 3 times, so on. If I is n, J loop is running for n times. The total, how many times the loop is running? 1 plus 2 plus 3 plus 4, so on to n. So this is like sum of natural numbers, right? N into n plus 1 by 2, which is nothing but O(n) square, right? Right. How did I break it? This will be like n square plus n by 2. Okay, now if there are number of powers here, okay, like suppose n to the power 4 plus n to the power 3 plus n to the power 2 n to the plus n, we take the most dominant term. Okay, so n to the power 4 is the time complexity. And guys, we are I think if you are confused here, we are just referring about the worst time complexity. Okay, we are not concerned about the average currently or the best time complexity. Okay, these all examples are based on worst time complexity calculation, which we discussed earlier, right? We are mostly concerned about the worst time of algorithm, not the best time. Okay, now guys, let's have a look. So what will be the time complexity of this algorithm? So how many of you have got most of your things correct? Okay. Okay, so now let me start. Let me change the color. Let's try this color this time. The complexity of this code is O(n). Okay, the complexity of this code we just calculated in the last example, right? The same question is there, O(n) square. Okay, so now it will be O(n) plus O(n) square. Which is the dominant term? Because this is separate, right? This is separate. First this will finish, then this will finish. The total time will be O(n) square. But this is the dominating term. So the time complexity will be O(n) square. Right? Great. Okay. So now for this problem, what do you think will be the time complexity? Any guesses? Simple. How many times this loop is run? It's a reverse loop, but still it's a loop. So this is running from n to 0, n to 0. So which is total? N plus 1 times, right? So O(n) plus 1, which is similar to O(n), right? Okay. Okay, guys. So these were few questions that these were very easy level questions. These are easy level questions. Okay. To discuss about the time complexity. So there are several things we learned about time complexity now. Number one, let's have a look over. Number one, what? We have to count total number of steps, right? The program will run. Simple. Like this program will run in n steps, n plus 1 steps. So the complexity is 1, right? This is, and sometime when you cannot calculate it normally, how do we calculate it? I write the value of I. If there are multiple loops, then I write the value of j. Okay, see the pattern. What is the pattern going on? And finally, we add them if there it is required to add, and then finally print the answer. Okay, so there are possible ways. Okay, using all the ways, these always will help us to solve. Now there are two more classes on iterative complexity also. One is a medium level and other is hard level. Like actually it's quite hard, so you need to be clear and thorough with this concept. Okay. Okay, guys, that's awesome. That's awesome. Yeah. So now this is the last question for this easy one. I hope you guys can answer it. I am not interested in answering this question. Okay. So give me the answer for this question in the comment. Okay. What will be the complexity of this? Simple. How many, count the number of times the loop is running, and that will be the complexity, right? Okay. Awesome. So I'll just give the answer. Uh, oh, and okay. If you need the explanation, it's simple. Like this loop is running for starting from 1. This will keep on increasing. That this loop will go from 1 to n, right? Total n times. Simple. Right? Awesome. If you have any doubts or something, do comment out, and we will discuss about those doubts. Okay. Not to worry. Just whatever you feel, go and comment it. Okay, guys, that's really awesome. Okay, so now we have done. Okay, yeah, and also during comment, if you see like what do you say, which question you are commenting on. Like if you want to write in the comment, I'm commenting it for the first question or the second question. You can use the page number, right? For page 14, the answer is this. For page 12, the answer is this, and so on, right? Awesome. Awesome, guys. Then I'll see you later. And okay, don't forget to like and subscribe the channel so you'll get the notification. Okay, for the other videos. Do click on the bell icon. Okay, if you click on the bell icon, you'll get a proper notification whenever the video is uploaded. Right? Okay, and don't forget to check out the course on Launchpad. This course will be available on YouTube as well as Launchpad. Okay. Okay, guys. Awesome. Then I'll see you. Bye bye.